Hey guys, it's time for another science lesson about stars. And so today I wanted to go ahead and teach about the kinds of stars. Last time we talked about the brightness of stars, we talked about the colors of stars, we talked about how hot and how cold they could be, we talked about the sizes of stars like supergiants and like medium and small stars, even like dwarf stars. And so today we are going to talk about the kinds of stars. So let me move this so you can see my board. And let's talk about some of these guys and what's going on with all these stars. All right, so the first kind of stars that I want to talk about are the variable stars, and you'll see those right here. Variable is just a word that means to change, and these are stars that sometimes they change in brightness regularly. So they might change, they'll be bright for a little while and then go dimmer again and then change to bright again and then go dimmer. Or sometimes it's just random where they'll just flare up and be really bright for a while and then fade away into just a much dimmer star. And we call these variable stars. And there's two kinds of variable stars that you'll see up on our board here. Number one here we have is the pulsating stars. And pulsate means to change regularly, and in this case, the pulsating star changes its absolute magnitude. Now, if you remember from our last video, we talked about absolute magnitude is the actual or true brightness of a star. So it's actually changing its own brightness, whether there's a change in the makeup of the star, something happens within the star to cause it to actually become brighter, and then take it and then become dimmer. And so that will be called a pulsating star. And it's called pulsating because the changes from bright to dim and back again make it look like make it look like it's pulsating or vibrating almost. Okay. And then our second kind of variable star is called eclipsing star. Okay. Now eclipse, if you remember a couple of years ago, we had an eclipse where everyone was very excited and they bought the glasses and everyone stood outside at the right time and put their glasses on so they could look at the sun, and they got to see the eclipse. And basically what the eclipse is when one object moves in front of another object and either blocks its light in some way. And so in that case, we saw the moon come in front of the sun. And when the moon came in between the earth and the sun exactly, we saw a ring of light around it, which is very cool looking, and you don't get to see those very often. With stars, eclipsing stars means there's a pair or two stars, okay, in this group, okay? And these stars change not in their absolute magnitude, but they change in their apparent magnitude. Remember that apparent magnitude is when the star, how bright the star actually looks. For example, the sun is a star, and it looks very bright because it is so close to us in comparison to all the other stars. So its apparent magnitude is very bright. So these stars will appear to suddenly be very bright or suddenly be very dim. And it's because one of these stars here is moving in front of the other star. And when that star shifts in front of the other star, it causes the other star to become much dimmer because we can't see it very well. And then when it moves again and they're not in alignment anymore, then all of a sudden that star looks a lot brighter. It didn't actually change its brightness at all, but it looks like it did. It changed its apparent magnitude, so we call these eclipsing stars. And those are our variable stars. And it's interesting because if you read in the Bible in 1 Corinthians 15:41, the Bible says, "One star differeth from another star in its glory," or in its brightness. So even back when the Bible was written, God knew, of course, he created the stars. He knew that stars would be changing in their brightness, and he chose to put it in the Bible. Okay, now let's talk about novas. Right here in the middle in the green right here. Nova comes from the Latin word that means new, and that's because these look like they are new stars that we didn't see before, and all of a sudden, they're there in the sky. Now, scientists in the past would call it like the birth of a star, but it really isn't. What we think really happens now, what astronomers think, is that there's an existing star, and all of a sudden, it will flare up and suddenly become hundreds or thousands of times brighter than it used to be, and so, or than normal. And so it looks like this beautiful bright new star in the sky. Okay. Now, just like these eclipsing stars, novas are actually part of a pair of stars. And the reason that we think, anyway, that they flare up hundreds of thousands of times brighter than they would normally be is that the other star in the pair's gravity is pulling on that star and causes that flare up. And it's pulling gases out of that star and causing it to flare up really bright. Okay. Now, novas are not very common. You see over here, I wrote, these are very rare. So they don't happen very often. In fact, you can't just look up in the sky and be like, oh, totally didn't see a star there yesterday. Look at that brand new bright star. You would need a telescope for sure. And even with telescopes, novas are only spotted a couple of times a year, usually, in our galaxy anyway. So that's what these novas are. Now you'll see, I took this nova and I surrounded it with this cloud of gas. And I wrote here, cloud of interstellar gases and debris. Now, these novas, when they flare up, they don't last very long. So they'll last for a little while and they'll be really bright in the sky. And then all the outer layers will float off into space and leave this much dimmer and smaller star behind. And this cloud of interstellar gases and debris that's left over and kind of floating in it, and it looks like these awesome galaxy swirls that you see a lot in outer space designs. And that's called a nebula. So that's why we have that right here. So when the nova shrinks back down and the gases and the things that are left over float around and make those beautiful purpley swirly shapes that you often see in those galaxy designs, that is called your nebula. One of the last nova that astronomers saw that was one of the brightest novas that you could even see without a telescope was Nova Cygni, and this was in 1992. And which is pretty cool because it's a very big and bright nova. Now, novas are cool, but then what about a supernova? All right. A supernova is a really nice name for the death explosion of a star. We don't know for sure, but scientists think that the supernovas occur when all of its hydrogen or its fuel is all used up. So when these of course are not dwarf stars. These are big, massive supergiants or giant stars, and they've used up all of their hydrogen fuel, and then the star starts to collapse in on itself, and it heats up very quickly because of the gravity of the star, and it just explodes. And so you'll see it when it explodes, it gets brighter and brighter and brighter, and then it collapses, and then it becomes one of two things. It can become a neutron star, which we're going to talk about in just a minute, or it can become a black hole, which we will also talk about. Again, remember how I said novas are very rare? Well, supernovas are extra rare, okay? They rarely ever happen. In fact, I put right here, the last one that we know about happened in 1604. So over 400 years ago, the last supernova that we know of happened. So they're extremely rare. However, when a supernova happens, it can often leave a really cool nebula that's still left in the sky today. There was one supernova that was observed by Chinese astronomers in AD 1054, and the remnants from that explosion formed the Crab Nebula. And that's the closest nebula to Earth that's caused by a supernova anyway. And I'll show you a picture of that so you can see. There's a picture of the Crab Nebula right there. Now, like I said before, when the supernovas explode and they lose all their hydrogen, then they become one of two things. They can become a neutron star, not Jimmy Neutron, but a neutron star occurs when, as the supernova is exploding, all of the neutrons and the pressure in the core of the star push down on those protons and those electrons and get rid of the protons or electrons, or convert them to neutrons, so that the core of the star is actually made of just neutrons. It's super tight, and it's just packed full of these neutrons. And it's so packed that it becomes extremely heavy. And when I'm talking about heavy, I'm talking about if you took a little teaspoon and you scooped a teaspoonful out of the neutron star's core, it would weigh 1 billion tons, just that teaspoon. So to even come up with a number for the weight of a neutron star would be truly astronomical. Now, neutron stars can come in a couple of different ways. They can just look, or they can just be like this, like a regular star in the sky, of course, with the heavy core. Or we have some, and you'll see this squiggly line right here, that we call pulsars. Now, pulsars are neutron stars that spin really quickly on its axis. So here's the neutron star, and it's still collapsing on itself. Remember, we said the supernova, when it has the death explosion, it's collapsing on itself, and it eventually forms either a neutron star or a black hole. Well, this time the neutron star keeps collapsing on itself, and it causes it to start spinning very rapidly and just flinging pulses of energy into space. And that's why it's called a pulsar. Pulses of energy, pulsar. And astronomers can find them because they can trace the pulses of energy that actually come down to our galaxy, and then they'd be able to bounce them back, reflect them, and find these pulsars. Okay. And then, of course, the topic we all wanted to talk about, everyone wants to talk about the black holes. Some astronomers believe that when a massive supergiant star runs out of fuel, remember the hydrogen is the fuel of the star, its gravitational force is so great that the core cannot stop collapsing. So it just keeps collapsing inside the core until eventually it causes a nothingness. But it's really a black hole. You can't see it, but it pulls everything into it. That's why I drew it kind of in the swirly fashion, and you kind of see the letters being sucked into it. It pulls light into it even. And that's how we know that they exist, because we can see the gravitational pull that it has on matter. We can see other things being sucked into it. We can even see light being sucked into it. We just can't see the black hole until last year. And so in 2019, a black hole was photographed for the first time. And that black hole was called M87. And that black hole, if you look at this picture, and you can look it up, it looks just like this fuzzy orange ring with a little black circle in the middle. And it doesn't look very big, but it's actually as big as an entire solar system. And it's about 6.5 billion times the mass of our sun. So these things are huge. They're just very hard to see, but they are left. Remember, the black hole is left after a supernova continues to collapse in and on itself. And then the light from those gases just seem to disappear, and that's why they call it that black hole. And these are our types, or our kinds of stars. And next time we talk about stars, we're going to be talking about one of my favorite topics, the constellations and the star pictures that we're going to see in the sky. And that's all for today. And I will see you next time. Have a stellar day.